Hi, it's me once again, your math solution provider. In this video, we'll be talking about fractions. Have you ever noticed that there are times when you don't really have to deal with the whole? When you need to deal with a part of a whole? That's what fraction is all about. Let's take a look at this. Assuming you have a circle, and the circle is divided into two equal parts, and one of the parts is shaded. This shaded portion is one out of two equal parts. And the unshaded portion is still one of two equal parts. This signifies the part that we're interested in, and this signifies the number, the whole, the number in the whole. Okay? Let's take another example. Let's say another circle, and with this time is divided into three equal parts, and we get to shade a portion. This shaded portion is 1 out of 3, so we have 1 over 3. That's our shaded portion, while the unshaded portion is 2 out of 3 equal parts. We have 2 over 3, which is the unshaded parts. So other common fractions are, we talked about 1 over 2, we talked about 1 over 3, we even talked about 2 over 3 as well. We can have 1 over 4, which can be called quarter, which is also called quarter. You can have 2 over 5, you can have 4 over 9, etc. You can have as many fractions as possible. Now, in this fraction, this one signifies, like we already discussed this shows 1 out of 4 equal parts. This shows 2 out of 5 equal parts. This shows 4 out of 9 equal parts. Okay? Now, all these numbers that are above the line is called the numerator. These are all called numerators, okay? And those below are called denominators. All these are denominators. Types of fraction. We have 3 types of fractions. We have proper fraction, we have improper fractions, and we have mixed fractions. For the proper fractions, the denominators are greater than the numerator. For the improper, the denominator is less than the numerator. Then the mixed fraction is where you have a mixture of whole numbers and proper fractions. So examples of proper fractions, what we'll be talking about: 1 over 2, we have 3 over 4, we have 4 over 5, we have 10 over 17, etc. Okay? As you can see, the denominators are greater than the numerator. 2 is greater than 1, 4 is greater than 3, 5 is greater than 4, 17 is greater than 10. Okay? But for the improper, we have the numerator being greater this time. So you can have something like 3 over 2. You can have something like 4 over 3. You can have 5 over 4. You can have 12 over 7, and so on. Okay? Now for mixed, we have both whole numbers and proper fractions. Something like saying 2 whole number 1 over 2. You have 3 whole number 3 over 4. Or you have 10 whole number 1 over 5, and so on. That's a mixed fraction to improper fraction. So let's take, for example, we have 3.5, which is a mixed fraction, and we need to convert it to an improper fraction. This 3.5 is the same thing as saying 3 plus half. Okay? And this 3 is the same thing as saying 6 over 2 plus 1 over 2. And when you add them, since they have the same denominator, just say 6 plus 1, which gives us 7 over 2. The other way, or the easier way of doing it, is by saying 3.5 equals 2 times 3, 2 times 3 plus 1 all over 2. And you have 2 times 3 to give us 6. 6 plus 1, 7. 7 over 2. Or let's try another example. Here we have 2 whole number 3 over 5. Okay? The same as saying 2 plus 3 over 5. Okay? Which is still saying 10 over 5. 10 divided by 5 is 2. Plus 3 over 5. Which will still give us 5. 10 plus 3. Which gives us 13 over 5. Or the second way, the alternative, the quicker way, is by saying 2 whole number 3 over 5 equals 2 times 5 plus 3 all over 5. So you say 2 times 5 plus 3 all over 5. 2 times 5 gives us 10. 10 plus 3, 13. So we have 13 over 5. Fraction to mixed fraction. Assuming we have, let's say, 3 over 2, which is an improper fraction, we want to convert it to a mixed fraction. Okay? This 3 over 2 is same as saying 2 plus 1 over 2, which is still the same as saying 2 over 2 plus 1 over 2. And your 2 over 2 is 1 plus half, which gives us 1 whole number 1 over 2. Or more quickly, if you have 3 over 2, you can just say 3 divided by 2, which gives us 1 remainder 1. It's 1 remainder 1. And that remainder 1 still divides 2, so it will be 1 whole number 1 over 2. That's 11 over 3. Okay? So 11 over 3 will give us 9 plus 2 over 3. Now we chose 9 because 9 is a multiple of 3, is the closest multiple of 3 to 11. Okay, so 9 plus 2. So you have 9 over 3 plus 2 over 3, which will give us 9 over 3 is 3 plus 2 over 3, which gives us 3 whole number, 2 over 3. Then the easier way or the quicker way of doing it is by saying 11 over 3 equals 11 divided by 3, which gives you 3 remainder 2. And that remaining 2 still divides 3, so it's 3 whole number, 2 over 3. This 3 is simple with this 3. So that's it. About equivalent fractions. Equivalent fractions are those fractions that are equal to each other. Let's take an illustration. Looking at this, you can see we have 4 circles. Now, I divide all the circle into 2, and I shade this part. And I decide to cut this into 2 again and still shade this part. I decide to divide it and still shade this part. I decide to do this like this, and like this, and still shade these parts. Have you noticed that I have shaded half of all of them? But in this case, I shaded 1 over 2. And in this case, I shaded 2 over 4. This case, I shaded 3 over 6. And this case, I shaded 4 over 8. So we can see from this illustration that 1 over 2 equals 2 over 4, equals 3 over 6, and equals 4 over 8. An equivalent fraction, whatever you do to the numerator, you do to the denominator. So, just the same way we did for half, let's look at 1 over 3. Okay? 1 over 3 is the same as saying 1 times 2 over 3 times 2, which is the same as saying 1 times 3 over 3 times 3, which is the same as saying 1 times 4 over 3 times 4, and it goes on and on like that. So you can say, it's safe to say that 1 over 3 is equal to 2 over 6 equal to 3 over 9 equals 4 over 12, and it goes on and on. Okay? Or you can take another example. You can say 2 over 5 is equals 2 times 2 over 5 times 2, which is equal to 2 times 3 over 5 times 3, which equals 2 times 4 over 5 times 4, and it goes on and on and on, which gives us that's 2 over 5 also equals 4 over 10, which is equal to 6 over 15, which is still equal to 8 over 20, and it goes on and on and on. So, given this question, you have to find an equivalent fraction of 3 over 7 that has 9 as the numerator. You ask yourself, what can I do? First of all, you find out the relationship between 3 and 9. The given is the numerator. So you find out the relationship between them. And you know that 3 times 3 gives us 9, or you say 9 divided by 3 gives us 3. Whichever one, it's 3 that you multiply by 3 to give you 9. So as you have 3 times 3 equals 9, so you have to do the same thing to 7. So 7 times 3 will give us what? 21. So 21 is our missing number, or the required number. Given a problem like this to solve, 5 over 9 equals box over 36. So trying to find out what should be in the box. Okay? And we know that the relationship between 9 and 36 is that 9 times 4 gives us 36. So as 9 has times itself, as we've gotten 36, we need to get the numerator the same way. So we multiply 5 by 4. So 5 over 9 equals 5 times 4 over 9 times 4, which gives us our box over 36. And 5 times 4 gives us 20, and that is the answer to the question. So given this set of fractions, and we are told to arrange them in ascending order, that is from lowest to greatest. Now, when looking at these fractions, you can't actually tell which one is greater or which one isn't. So the only way to do it is to give them a common denominator. That way, you're able to tell whether one is greater or is lesser. So what do we do? What's the first step? That's where the knowledge of our LCM comes to play. Now you're supposed to find the LCM of the denominators, all the denominators of 2, 5, 15, and 30. I'll let you solve that on your own, but I'll give you the answer. But do make sure you practice how to get the LCM. So the LCM of 2, 5, 15, and 30 is 30. Now, we're going to make all of them. We're going to make all of them have the same denominator, which is 30. That way, we're able to tell which one is greater. So now, how do we do it? Let's make half. Let's find the equivalent fraction of half with a denominator of 30. So you ask yourself, what is the relationship between 2 and 30? And we know that 30 divided by 2 is 15. So that means 2 times 15 is 30. So we now have 1 times 15 is 15. So it means we have 15 here. So if we want to do for 3 over 5 equals box over 30. Okay, we have 5 times 6 equals 30. So multiply this 3 by the same 6, and 3 times 6 will give us 18. Okay, we have 18 here. Let's look at 8 over 15. Okay, relationship between 15 and 30. Now 15 times 2 gives us 30. So 8 times 2 should give us 16. Then look at 17 over 30 should give us, since it maintained 30, 17 over 30 is the same thing as 17 over 30. So sorry, we have 16 here, and we have 17 here. So now, looking at them, they have the same denominator, so it's easy for us to tell which one is the lowest and which one is the highest. So if you are to arrange them in ascending order, you have 15 over 30, 16 over 30, 17 over 30, and 18 over 30. And that gives us 1 over 2, 8 over 15, 17 over 30, and 3 over 5. And this, my dear friends, is the answer. So now let's look at the lowest terms. Finding the lowest terms of a fraction. You know, just the same way we did for equivalent fraction, where we had to multiply the numerator and denominator by the same number. This time, you get to divide the numerator and the denominator with the same factors they have in common. Okay? So this time it's like they have bigger numbers which you need to reduce to its lowest term or its simplest term. Okay? So let's take, for example, we have a number like, we have 15 over 20. And we are to reduce it to its lowest term. You can say they have a factor in common. That's our HCF. That's why we've been studying LCM and HCF. You have common factors here. Looking at the two of them, you can see that 5 can go. So 15 over 20 is same as saying 15 divided by 5 over 20 divided by 5. It's important to ensure that whatever you're doing to the numerator, you're doing it to the denominator. Very, very important. Otherwise, you miss it. You miss it entirely. You miss your way. So it's very important that whatever you're doing, since you're dividing by 5, the numerator, divide the denominator by 5 as well. So when you divide it, you have what? You have 3 over 4. Another one, we can look at 24. Let's look at 24 over 30. Okay? You can say, we are sure 2 can go between the two of them. So 24 divided by 2 and 30 divided by 2, which gives us 12 over 15. And looking at it again, we can see that 3 can go. So we can divide this one by 3, divide this by 3, and we have 4 over 5. And that's the simplest term for 24 over 30. Now, let's look at 42 over 70. Let's try to reduce it to its lowest term or its simplest term. Now, that way I showed earlier is me trying to teach you. Now, when you're in a real examination condition or real solving condition, let me show you the simpler and easier way to go about it. Let's go. Now, looking at 42 and 72, what should go? 2 is a common factor. So you have 42 divided by 2. So instead of doing that long distance, I just divide 42 divided by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. That's 21. And 70 divided by 2, cancel 7, you have 3. Remainder 1. That 1 here, 5. Now looking at 21 and 35, what's their common factor? 7. So you divide 21 by 7, you have 3. And you have divide 35 by 7, you have 5. And so, my dear friends, 42 over 72, its lowest or simplest term is 3 over 5. I'm taking another example. We have 28 over 36. Common factor 2, because they are both even numbers. So 2 goes here, you have 1, 4. And if 2 goes here, you have 1, 8. And they're still even numbers. And you can, so 2 can go again. So 14 divided by 2 gives us 7. And 18 divided by 2 gives us 9. And so, my dear friends, we have 7 over 9 as the simplest term for 28 over 36. I hope you found this video useful. Please look for a good math textbook that treats this topic and solve as many questions as possible. If you have any questions, any queries, or any topics you want us to discuss, please use the comment section. Please like, share, and subscribe to my channel. Thank you.